Hello, my name is Peter Rayner and I'm an engineer born and bred.
So how did you get started? It was an unconventional route?
It was yes, why did I start as an engineer? It was an unconventional route, but I think it was, in a sense, predestined in that I was brought up not actually in a garage, but my father was manager of a garage. He was manager of the garage, and so we had no garden or anything like that, so my playground was the garage. And so I had tools at a very early age. And there's a story, maybe apocryphal, that one of my first presents was a junior hacksaw, with which I hacksawed my cot. There is some evidence that this is true, because the cot's still in the family, and there are saw marks down it. But whether it's true or not, I don't know. So my father was an engineer, ran a garage and then later a machine tool company. And I was always interested. I had my own lathe when I was about 14, 15, little lathe, little workshop. I passed the 11 plus, so I went to the usual grammar school. I was a bit irritated because I was in the A stream, and so I had to do Latin, whereas the B stream were allowed to do engineering drawing, and I tried to swap, but I wasn't allowed. So it got to 16. I did usual O levels, and I thought, right, now I'm going to be an engineer. And it's slightly irritating in a way that I was never told that engineering was a university subject. So I went off, got an apprenticeship at Pi, was the local electronics company. It was a big outfit then, taken over by Philips ultimately. And I was an apprentice there and did the usual thing of moving every 3 months to a different department, dipping transformers in tar and all sorts of horrid things. But part of the apprenticeship was to go to the local tech college 1 day a week. So I started doing that Ordinary National, and that carried on. After about 2 years, I was extremely lucky and got put into one of the laboratories of Pi television transmission, the audio laboratory actually.
When would this have been?
What sort of year? So I'd have been about, I can't do years very well, I'd have been about 18. And I was put in there to help with wiring, but two of us were, two apprentices, but it turned out that I was sufficiently nosy to look over the engineer's shoulders, and eventually got decided that I wasn't really any use as a wireman, and that I ought to be an engineer. And that person that took me under his wing was Gordon Edge, who went on as MD of Cambridge Consultants, founded PA Technology and Science Centre, then Scientific Generics. And he was my mentor, and that's a tremendous influence, because we had, it was marvellous. We had a project building a 34-channel transistorized sound mixing system for Tyne Tees television, but the senior engineer was in Australia, so it was entirely our project, and that was absolutely marvellous. But there was a strict deadline, so we were working very, very late, 3 o'clock in the morning, on a regular basis. But I was also, at that time, it was my exam, so I was doing my revision in the lab in the evenings, and what really stimulated me, we were doing valve theory then, vacuum tubes, long before transistors. I was trying to work out the impedance of a cathode follower, which is a piece of technology, and I said to my mentor, Gordon, what's the input impedance? And he thought about it, and actually worked it out in his head, and I thought, right, I got to do something there, I got to be more serious about this. So anyway, at the end of the apprenticeship, I did rather well in the exams, and went off to Cambridge Consultants. I was their first sort of public employee.
Sorry, this is right at the early days of Cambridge Consultants.
Oh, absolutely, yeah. I mean, it was, I think it'd probably been founded about a year before I joined. It was sort of interesting because we had this shambolic laboratory come workshop along Histon Road, but the offices were in Jesus Lane, so we all used to go down to the office at lunchtime, and the secretary would make soup. It was a marvellous atmosphere. I mean, the place was full of eccentrics, and it was really, really good.
So who sort of sticks out in your mind when you're talking about a place full of eccentrics?
Well, yeah. One of my first projects there was on Apparatus, which was a big dome. Inside was a vibrator, a loudspeaker, essentially, and that was to vibrate bees' wing muscles. And it was a project for Professor Pringle at Oxford, and it was a Royal Society grant. But all the other directors were completely eccentric, didn't bother to turn up on Saturday mornings when the Royal Society adjudicator came along, who happened to be one Huxley. So every Saturday morning for about 6 weeks, I had to entertain Professor Huxley. And I was sort of 19 by the 20 maybe, that sort of stage. It was an enlightening experience, just the sheer intellectual power. I mean, he knew nothing about electronics when he came, and I suspect he knew more about it than me when we finished. So that's an example of I think, in a sense, how lucky I was to be in the right place at the right time. I mean, there are lots of other examples. There's a tremendous one. I don't really remember. There was a pop singer called Screaming Lord Such, and his manager came along to us and said, well, first of all we did a radio microphone, long before there were radio microphones for such, but he also had another protege. What he wanted to do was, in the night in London, he wanted to tether a gas balloon and put his protege in it, and somehow or other the moorings would break, so the protege would go off in the balloon, but then he'd remember that his protege had got this radio in his pocket, which was tuned to BBC. So the idea was that BBC would then be forced to put... we didn't do that, John. It didn't come to anything, but hey, it's sort of typical. Anyway, what happened was we were growing quite quickly, and I was, by that time, head of digital electronics, which sounds grand, but it was very small. But I was actually employing graduates. And I thought, well, I don't know, maybe I ought to get a degree, because I got higher national and membership of the Institution of Electrical Engineers, but I hadn't actually got a degree. So I went to see my old tutor at Tech, Nat Hiller, and he said, well, don't bother with a degree, do a PhD. So I thought, well, that's quite interesting. So I wrote around to all sorts of universities. And the University of Aston actually offered me a place, which I thought was pretty good, actually. A bit of a risk.
Did you have to go for an interview and things?
Yeah, I went for an interview, and I was married and had 2 children, so I needed funding. And I applied for something called a Whitworth Fellowship. I don't think they exist now. But I came back from holiday, was interviewed for that, and they said, yeah, good. And I thought, that's the financing fixed up. And they came through after a bit and said, once you pass the interview, you're too young. Which was a bit rotten. Anyway, eventually I got an SRC studentship and did my PhD at Aston.
What was that like as one of the red brick universities, isn't it?
Yeah, and I was one of the first 3 PhD students, actually. My supervisor, Professor Flood, had just come from industry, so that was sort of quite interesting. He wasn't an academic, he was a bright man. But yeah, it's around about then I began to sort of realise the power of mathematics in engineering. And my PhD was on pulse duration modulation, which is just a way of making very, very efficient audio amplifiers. But I did some quite deep analysis of that, and so I got really involved in mathematics. And I began to realise that I wanted to move out of electronics as such and get more into communications and so on. And I got, at University of Essex, they offered me a research fellowship in speech recognition a long while ago. And I thought, yeah, that's great, I really want to do that. But as I said, I've got 2 children, a wife and 2 children, and the grant kept not coming through. It had been granted, but the money wasn't there from government. And I couldn't hang on any longer, and a lectureship came up at Cambridge. So I applied for that and went along for an interview, and it was asked what I wanted to do, and I said, well, I want to swap from electronics into communications. And I mean, it turned out they wanted something in communications, but then asked me some questions about communications, and I said, well, I just said I don't know anything about it. And I think I was sufficiently, having spent a long time in industry, I didn't suffer fools gladly. And I think it went down extremely well, actually. It was for a full lectureship, and I was too young for that. They created a junior lectureship for me, which was fine. So I thought communications, and not long before that, a new computing algorithm called fast Fourier transform had been developed in America, and it made, and the technical details don't matter, but it made some particular processing. You needed 1,000th the amount of computing that you did previously, and it was just a clever way of doing it, which just shows the power of algorithmic development. I was very impressed with that and thought the idea of digital signal processing is a new one, and it's probably a good place to be. So we wanted to do digital signal processing, so we needed digital computers. The department engineering, this is the engineering department at Cambridge. We had an old IBM 13 something, 1103, IBM 1103, which I think, like all computers at that time, had about 12K of core store. I can't remember whether it actually, I think it did have disks, they're huge things which you plugged in. They were generally that diameter and that thick. And I mean, I guess they're probably a few megabytes. I doubt it'd be more than that.
Mm-hmm. How big was the whole machine then?
The whole machine would be, 3 meters long, something like that. 3 meters long and about a meter wide. The input-output was interesting because it was just a teletype. You had no VDUs. It was long before VDUs, and so the medium which you carted your programs around was punch paper tape, which is paper tape about that wide with 7 or 8 holes across it, and minor editing you did with a little paper punch, which if you got a wrong character, you could sometimes modify it with this paper punch on a. It's a tedious business. However, it's pretty exciting. And you had to book on the computer for the whole engineering department. You could book, I think it was 10-minute, it might have been quarter of an hour slots. And so you can imagine if you've got a bug, you have a quarter of an hour and then you go away. It was. But so we had that. But about that time, one of my undergraduates, Nick Kingsbury, who's now Professor Kingsbury and head of the group, but we actually set up the first real-time signal processing. There's an undergraduate lab, and about 500 meters away is the computer room. So we strung wires up, and so in the lab we had signal generators and analog to digital converters, which went off to this IBM, and I think we could display a sine wave, and that was about it. But I mean, it was exciting times. We were just getting to the stage where you could actually think about doing things. Using the department computer, we obviously needed one for the research, so I got an SRC grant, Science Research Council grant. I think it's about £25,000, but with it I bought a Data General computer, which was about the equivalent of the PDP-8s and the digital equipment ones. And it had a grand 12K of core store, quite something. I can't remember how much it was a lot of money. But I bought a fixed head hard disk to go with it, which went 18-inch rack mounting thing, and it had a capacity of 256 kilobytes, and it cost £5,000. Yes, it's just staggering when you compare that with what you get. Digital electronics must be about the only thing where the prices are essentially dropping enormously. So we had that as our first computer. Lots of PhD students going through.
What was the relationship like with the PhD students? I mean, how did your lab function? Because everyone's got their own philosophy.
I ran it on a very, very informal basis. Yeah, I mean, we every Friday night, the group was quite small then, probably 8, 10 students maybe. Every Friday night we used to go out for curry, or to the pub, and then for curry along Regent Street. So it was very informal, and it was a real fun time, and I had absolutely excellent students, and I think of them, I think 10 are now full professors, and a millionaire, a billionaire, and so it really was good fun. Our next computers were BBC computers with a floating point coprocessor. No, they were actually quite good, but I mean the advantage was that everybody could have one, whereas the old Data General machine, you just had one machine for 10, 15 students. However, there are lots of things we couldn't do. One of the things I set as an undergraduate project was to make noise-cancelling headphones. And funnily enough, the person I set it to is Mike Lynch, who did a PhD with me and then founded Autonomy, and he's the near billionaire. And, but we decided we just hadn't got the computational power to make it. I just wish I'd put a patent in for it, though. Anyway, I didn't. So the next step in the group was growing all the time, and I can never remember quite what stage, but it ended up with 6 academic staff, a computer officer, about 30 PhD students. So it was a big, even on an international scale, it was a big signal processing group. And we, in 71, 72, we organised in London, Imperial College, the first sort of international conferences on signal processing, and people came from all over, but there weren't that many people working in it, but it was obviously a growing subject.
Had you already got contact with those people as part of the research? Because science generally, and research generally, is a cooperative process, isn't it? Where
Yeah.
Well, and competitive. But
yeah, it is via publications. I mean,
yeah.
if you want to get on in the university, you've got to publish. So the whole emphasis on publishing. So you publish in international journals, and then you correspond. Somebody publishes a paper, you write to them and say, yeah.
Was there a particular group that you were worried about in terms of competition, or
not worried about it. In the UK, there were 3 groups really. Us and Imperial, and Strathclyde in Scotland. At that time, it was really us and Imperial. In America, it was Bell Labs and MIT. So we had a close relationship with all of those. And, but it's a subject that absolutely mushroomed. I mean, it's a huge subject now. Because, I mean, virtually everything's got digital signal processing in it. Phone is full up with digital signal processing. Any communications device. Camera will be full up with digital image processing. And, it became a very statistical and mathematical group, but we were interested in real world problems, but we looked for generic solutions rather than trying to solve particular problems. So essentially they were algorithmic or mathematical solutions. But one of my favourite projects was we were approached by the National Sound Archive, which is part of the British Museum, part of the British Library, but they keep all the nation's sound recordings, all gramophone records, wax cylinders, everything, all in cellars somewhere along in London. But they just bought a very expensive sound mixing desk, massive thing, and they came along and said, we've got this digital sound mixing disc. What we want to do is restore old gramophone recordings, take all the clicks and hisses and bangs out of them. Can you tell us how to do it? And I said, well, essentially, no, but if you'd like to give us a research grant, we might be able to. Which they did, and funded a PhD student, and after that a postdoc. But so we developed algorithms. It's sort of quite interesting. Because you imagine an old recording vinyl or 78, which has been broken and glued together. Then there will be 2 big clicks as the thing plays. Well, you can detect a click rather easily. So you digitize the whole thing. You can detect a click rather easily because it's just huge, it's short. And then what you can do then is just throw the click away, and then using a modelling algorithm, a mathematical algorithm, you can take the music preceding and after the scratch and predict what should have been in where the scratch was. And you can do this remarkably accurately. The ear can't hear it. So a lot of work was done on that, and removing general sort of noise, the sort of shh type of noise, and reasonably successfully. So successfully that it was decided that we want to set up a company to try to do this commercially. And the British Library was the driving force really, but they got money from Cable and Wireless, a communications company, and they insisted I had a shareholding just to keep me sort of tied in, which is great. Now, there was a huge amount of serendipity because we'd just done this work just as CDs were coming in, and all the record companies wanted to transfer their vinyl recordings onto CD, but they don't look after the vinyl recordings very well. So they're dusty and they're ticks and scratches. And we were able to remove a lot of that, and the company grew. It's still going. We've won.
What's the company?
The company is called Cedar Audio. We've won quite a lot of international awards. BBC use our systems all the time. I've never seen it, but I think Come Dancing is a programme, and they do interviews, and they've got our dialogue noise suppressors going all the time. Star Wars, the original one, the soundtrack was remastered using our system. So it's a small company of 10 people. We're out at full board. 10 very bright people. And, so that was a very successful research project, and 30 years later the company's still going from strength to strength, basically. I'm still a director of that company. Along the way, I picked up a readership and then a professorship. My reputation was really founded on my students. I'm astonishingly good at recognising very, very bright people and persuading them to come and work with me. And yeah, it's a very useful talent.
So that's an interesting one, is how do you identify talent? What is it that you see? So if you think about some of the people that you had who joined you, what in those initial interviews and conversations were the things that might have triggered you? So think of an example or two.
Yeah. I can't, I need to think about the PhD students, but I can give you an example, which I rather enjoy, about an undergraduate who, well, he wanted to be an undergraduate. He came to me and he was in the RAF, and he'd got a higher national certificate in electrical engineering and an HNC in mechanical engineering. He came to see me and we were talking, and he said he's building an aeroplane. And I said, well, that's interesting. I said, well, tell me about it. He said, well, started off, he said, I couldn't know where to build it, so I built a shed. Then it went on and on. He built the propeller for this thing. It's absolutely beautiful. It was laminated wood, and then he somehow machined it. And it was a work of art. And I think he even built the heater to go in his. And so this is a man with enormous drive and so on. So although he's got a strange background, I said, yeah, we'll take you on. And it was sort of interesting because the first year he got a third, and oh dear. But the second year he got 2-1, and the final year he got a first, I think. And I think he last time I saw him, he was lecturing in mechatronics in Singapore, actually. So it's that people seem to show a spark. It's extremely. I suppose if I could think how one does it, I'd write it down, and it'd be quite a useful piece of information. But it's almost enthusiasm. Well, and an analytical mind, but you can get a lot of analytic minds, which it's like having a very high-powered shotgun. Without any sights. Well, I don't know, the shotguns don't have sights, but you can imagine a lot of people are very bright, but they don't really know what problems to solve. Or it's a more rounded person. Clearly, they've got to be bright. They've got to be highly motivated as well, and just find them. They're interesting people, but they're also they're interested in many things, not just the technology. A little small example is that in our research group, we always had a Christmas dinner, and we always had a musical performance after dinner, because there's always, at the very least, a barbershop quintet, and they just cite Red. But we often had, never had an orchestra, but we had bands, and it'd be, I think, without exception, every year, for 30 years, we've had musical performance from within the group. Now, whether there's some sort of affinity between engineering or mathematics and music, I don't know. And, people say there is, but I'm not sure there's any real evidence for it, apart from circumstantial evidence. So, I mean, along the way, I've been fortunate in being associated with a lot of people in industry as well, particularly the Cambridge phenomenon. There was a large report written on how the Cambridge phenomenon came about. I don't actually believe almost a word of it. I think it was essentially a critical mass of people. There were the Cambridge Consultants people, Gordon Edge, and others, but not, you know, it was a big handful of people. I think it's them, and again, it's these people that have the spark that set it off.
Did you also help that Cambridge was a relatively small place, really?
I think it does, yeah. And I mean, a lot is made of the influence of the university. That I'm unconvinced about as well. I mean, I think it has big influence now. Not meaning Trinity built the science park, but I think it was that core of people who were just excited about everything to do with technology, and that made it happen. And then that brought people in, and of course the university being there as well it is another draw. And subsequently the university spun out quite a lot of companies, very successful companies there. And my audio company is essentially, although it's funded by Cable and Wireless and the British Library initially, the university had a substantial share in it, and still has a share of some sort. So the university has been very, very good, I think Cambridge particularly, about supporting people who want to spin out, make something of their technology. I've spoken to people in other universities who have real trouble with.
I mean, the way you're talking about these things and the way that we hear them from others, there just seems to be this ferment of ideas, and everything seems possible. You know, if you put your mind to it.
But
do you think that that's different now, or is that?
No, I think it's still. I think it's still very much the case. I know quite a lot of. I'm a fellow of Christ, and a number of our fellows are entrepreneurs and doing well. In fact, one, something in chemistry, I don't know who it was, but I know he sold out a couple of years ago for 65 million. So he's doing okay. No, I think it's still a very exciting place in the sciences. I mean, I don't know about anything else, but I feel very privileged to have been part of all this. It's as I said, there's a huge amount of serendipity about it. You know, I was in the right place at the right time, with particularly with audio and digital audio and audio signal processing. What I haven't mentioned is we also did quite a lot of image processing, video processing, again funded initially by the British Library, restoring old movies, and that was. We ended up with a big EU grant. It was us, a French university, and a couple of industrial outfits, and we produced a system for restoring old movies. You know, you get the big scratch going down them, and then it looks as though there's a snowstorm as well. So we did a lot of work on restoring that, and the research student doing it, Anil Cockeram, he's an undergraduate with me, then a research student, and then a postdoc. Then he got a post at Trinity College Dublin, where he carried on with that work and set up a little company called Green Parrot, which was subsequently taken over by Google, and he's gone with them, at least for the time being. And any video that's presented to YouTube, which is part of Google, goes through his system to improve the quality, basically. So, yeah, there's some huge areas of digital processing which probably vastly more than actual computing. We all talk about digital computers, but most of digital processing is not in computers. It's in your iPhone and in your camera and so on. I mean, it's absolutely pervasive.
Was that part of the evolution, though, in that you started off with very big machines with limited capability, and then as the capability expanded, and then the fact of it being a computer as such, it was a computing unit, or it's a calculating unit, or it's a processing unit, then it evolved into various equipment.
Yeah, exactly. I mean, you take people like Arm, who make the processors of most of the world's, or at least they license the technology of making the processors of most of the world's telephones. I mean, they're very powerful, but very specialised processors. And I was sort of quite interesting. Another big application area of digital processing, of course, is in games, and we know all about that. But most universities have now got substantial research groups trying to find out how you can use these incredibly fast gaming chips to do general purpose computing. They're not well suited to it, but because they're made in such huge quantities that they cost next to nothing, so you can afford to have millions, well, at least tens of thousands of these little processors. But there's a lot of theoretical work and needed to find out how we can actually do it. I mean, the way the computer works is that you have quite a small set of instructions. Move this number from here to here, add this number to it. So a few things like that. Well, something for games playing has a very, very limited instruction set. Most of its work is moving pixels around an image screen, and that needs a very high speed work, very high speed processor, but a rather specialised one. So how can you do general purpose computing with this type of chip? And I don't know, but I mean there are big research groups working on it, so it's obviously a problem of interest. I can imagine it would be.
So what's your current interest?
Gardening, mainly. No, that's absolutely untrue. For various reasons, I'm going. My hearing's going. So we're hearing aids, but they're absolutely useless in the sense that they're good here, just us. But if you're I went into college a couple of lunchtimes ago, and I wanted to speak to the people across the table, but everybody's talking. I couldn't hear a thing. So, and it's called the cocktail party effect. When at a cocktail party, everybody's speaking. You can't differentiate between conversations like in the way that I was able to when I was young. It's a common phenomenon with age. Now that's a really interesting technical problem. If you've got say you've got 4 microphones and you've got 4 people speaking, is there any way you can take those outputs? So each microphone will have a slightly different mixture of the 4 conversations. Can you actually take those 4 outputs and microphones and then do digital processing on it to actually separate out the 4 conversations? Well, the answer is not perfectly, but you can do it pretty damn well. It's getting better all the time. It's called signal source separation, and I started working on it when I was still in the university. I still have a very active interest in it, and I think before very long we'll see devices on the market that contribute a lot.
Processing is predominantly done by the brain, isn't it? In terms of taking in two.
There's some different levels of processing in the ear. I think some happens in the inner ear and some actually in the brain, but I think the brain bit is the bit that gets degraded with age. I don't know why. Anyway, I mean, it's a common phenomenon, and if you think there are, I don't know, 500 million people in the world suffering from this, it's a big market. So if you can solve the problem, you're doing quite a lot for... Well, A, you're doing quite a lot for humanity, and B, you're doing quite a lot that could make a big profit.
So, in your whole career, you've been looking at, if we're looking at computing within the career, the computer has always been a tool that has improved over time. Was it the questions that are more important, or was it the computing that was important?
That is an interesting point, because the questions are important, but you had to realise at any time that there's only some of those questions you could even attempt to answer because of the lack of computing power. As computing power went up, you've tackled more difficult theoretical problems because you knew you had the potential. So it's gone hand in hand. One drives the other, and I find that really quite interesting. I mean, latterly, when I was in the engineering laboratory, the statistical work we were doing for signal processing is called sort of Bayesian statistics, and what you can pose a problem in signal processing in a statistical framework, and you get lots of really nice equations, but you can't solve them. So what you do actually, now we have sufficient computing power, is simulate them. So you tell the computer to generate random numbers, exactly like an audio signal, for example, and then you can do all your processing on using that. And
It's almost it's high speed modelling.
yeah,
And
very much
experimentation
so.
in
Yeah,
effect.
oh, absolutely, yeah. And that's really it's an interesting area because the engineers really wanted to work on the sort of Bayesian modelling and so on, and a lot of work, creative work, was done by engineers. There was a period in my lab actually where we'd got two young French researchers, absolutely fantastically bright, and they were really, in my opinion, the top men in the world. They were engineers. So for a few months, our lab became the sort of centre of the universe for statistics, and people were flying in from all over the world just for the weekend to sort of talk to each other. It was a really exciting time. I mean, these things never last very long as people catch up and so on. But the two young French researchers, one's a prof of statistics at Bristol and the other one prof of statistics at Oxford. It's sort of quite interesting that it's an area of mathematics that was actually driven by engineering. And there aren't too many of those.